So, good morning, everybody. It's a pleasure to have here today and for the next couple of days Gerard Ecker, who is professor of pharmacoinformatics at the University of Vienna. We personally met at the beginning of 2000, where we started a collaboration in the framework of an European project, which was named Europin. It was actually a training for PhD students in the field of pharmacoinformatics. And indeed, Gerard is here for a course to students, PhD students on pharmacoinformatics in the framework of the project Vitality. So I would like to ask Gerard to introduce briefly himself and to remember somehow our early days of collaboration. Please, Gerard.
Yeah, thank you, Antonio. It's very nice to be back in Perugia. As I always said in my talks, I'm somehow Italophilic. So I like being in Italy. Actually, the relation to Perugia goes back even further when Roberto Pellicciari and my supervisor Wilhelm Fleischhacker, they met, and we started also to exchange students and then going with European, as you said, with this European PhD in pharmacoinformatics, where we then pooled in Europe our PhD students to give them, let's say, also a sort of a structured training in all the methods. What we are doing scientifically is based, starting with modeling transport proteins, which are important for resistance in cancer. We moved more and more towards predicting side effects and toxicity, with the current aim to reduce animal experiments. So are we able to make very, very early in the drug discovery process at least an estimated guess what would be the main potential risks for this compound being put forward? And this is not only for drug discovery. We are currently in an EU project where it's about insecticides, agrochemicals, and also chemicals, REACH. For a modeler, it's a bit a nightmare. These small molecules, our methods are made for drugs, but there we also try to develop a sort of tools and also a workflow how we can do a very, very early risk assessment.
So Gerard, we also, know each other for many years, through conferences and workshops, but just now we are ready to start a collaboration. So today you are here as an expert consultant within the Vitality project. So as you know, we are working on the development of small molecule inhibitors for the biofilm formation on different surfaces. And this is very important for the generation of novel biomaterials. And you are an expert of toxicology prediction for small molecules. So why is important your presence here today, and how you can support us in the development of safe biomaterials?
Yeah, predicting toxicity is quite a complex matter, and because at the end you need to convince the regulator. And this is of course, there's a big responsibility, because when you overlook something, it really harms society. It harms patients or it harms society. So it's very, very important to be, on one side, conservative in the methods, and on the other side also try to utilize all these new AI tools to finally be able to, I guess the advantage of the AI tools is that they can handle all this massive amount of data which are somewhere out. This we cannot longer do in our labs. The disadvantage, of course, is it's black box, it's very noisy data, and the risk for what we call hallucination is there. I do that with the students. But I guess we need to include these methods, and my aim would be also while I'm here and giving the seminar, to bridge this and start with the very conventional methods which are currently used in industry, these similarity-based methods, this read across. How can that be translated to including these new tools we are basically constantly getting on our desk? It's just a question how good they are.
Yeah, and this will have a great impact on the different sector from healthcare products or for agri-food. So very important, I mean, to measure the safety assessment of these small molecules.
Yeah, we need to be, I guess what's also very important, what's quite often overlooked, especially when it comes to agrochemicals and chemicals, is risk and hazard. So risk is including exposure. So what they are currently doing is, even if a compound might be risky, it's important, do we reach the concentrations in humans when spraying something over a field? Is there the potential risk that the accumulation reaches a level where the compound really starts interfering with the biological system? So this is, I guess, currently also our big safety, that normally we don't reach these high exposure levels. Because what we did, for example, we recently did a modeling of metabolites of insecticides, and we saw that you had a factor 1000 potentiation of the toxicity risk of one of the metabolites. But still, luckily, we are far beyond the concentrations which we might reach. So this is it's very complex, and it's very important when it comes to chemicals. No new chemical, because no new animal experiments, and the animal experiments are still driving the risk assessment. So there's more or less a ban of animal experiments. So how can we combine in silico methods and in vitro methods to be sure enough that the compound is safe? This is the current challenge and the current aim.
Thanks again, Gerard.
Yeah,
Also,
it was a great pleasure to have you here today. I mean, in these days, as Antonio said, also for the PhD student. Thank you so much.
Yeah, no, you're welcome. I really look forward to interacting with all your young PhD students.
Would be great.
That's the pleasure we have at the university, always having young people around us.
Right. Thank you, Gerard.
Thank you so much.